Welcome.
This is CrimeBot.
Starting with the web page in front-end code, this is our web page. Although the webcam is currently disabled, functionality will be shown towards the end of the video. It includes a toggle light and dark button. There is a person summary box on the right side where the information of the suspect is displayed. There is a logo in the bottom left with information briefly mentioning what CrimeBot does and its goal. And the stop and start capture buttons which begins and ends the surveillance. This is the HTML file for CrimeBot. It is a very simple implementation for the buttons and words displayed on the web page. This is our CSS file which styles the web page and allows for light and dark mode, the webcam or video container in the middle, and a pop-up text box for the About Me and much more. This is our JavaScript file which includes code for the interactive UI portions of our web page. However, the main code in JavaScript file is the connection between the front end and back end of the website. We used WebSocket for real-time interaction between the server and the client. WebSocket allows for two-way communication between the server and the web page, and this was essential for various portions of the CrimeBot. For example, capturing the frames from the webcam and sending them to the server is critical, but it also happens simultaneously while displaying results from the server, including the information for the bounding boxes predicted by YOLO to show where the person's face was located and person summary results.
Now for the backend, which includes the fast API server and general logic where CrimeBot's face and feature identification actually happens. The general idea behind this logic is the following. So first, the frames are received from the webcam through the WebSocket connection, and then these frames are then run through a pre-trained YOLO model specifically made to detect human faces. Once the YOLO model detects faces in any given frame, the frame is cropped down to just the face. And if the YOLO model has above an 80% confidence that it is in fact a face, the face is pre-processed and run through the first and second CNN model, which extract demographic information and extract the probabilities of 28 different facial features being true or false, respectively. These model weights, as well as their architectures, are called in the main logic here to be used. The two CNN models output feature vectors which are then combined, and each feature is given a name. These vectors include everything needed to make a concise paragraph and are fed into the GPT API to make a well-formatted and human-readable description. It is not, however, used to detect the features of the person. Some other things that were implemented to make CrimeBot's process easier and faster is how we handled multiple people being in the frame. When YOLO detected multiple people in one frame, because only one frame is processed at a time, we could process these faces sequentially and label each one as its own ID, depending on their location using the bounding boxes. We set it up so that if the bounding boxes of the faces were too far apart from frame to frame, CrimeBot was able to assume that it was a different person and a new ID is created. Whereas, if the face was in a similar location, it could be considered as the same person. This is helpful because we used it to prevent finding facial features and outputting paragraphs of the same person multiple times. And this same ID system is used throughout the entire pipeline to output to the web page the bounding boxes for each ID and the person summary. Thank you.